Alright, we spent a lot of time with Newton's first law just to get you used to the idea of a free body diagram, to introduce friction, things like that. But now we're going to start applying all of that information that we know to Newton's second law. Alright, if you remember, we went briefly discuss what this was. It's the equation, your force is equal to the mass times acceleration. Alright, so another way to think about this is the law of acceleration, or the law of unbalanced forces, meaning your net force is something other than zero. They don't all equal each other and cancel out. Okay? So, the two following force diagrams most commonly represent Newton's second law. Alright, we have an object that is moving to the right and speeding up, i.e. acceleration. Or we might work with objects that are moving to the right but slowing down. So that would be deceleration. Either way, you have an A value to solve for. Alright, just keep in mind, for acceleration, A should be positive. For deceleration, A should be negative. Not necessarily -1, but just a negative number. Okay? So, let's talk about what this actually looks like on a free body diagram. We've seen some of these before. If you remember that worksheet that we went over and over and over with, as far as, getting the net force, labeling it first law or second law, and so forth. So let's talk about a free body diagram where our mass is 12 kilograms. Alright, so from here you should be able to figure out F sub g. Alright, that's going to be your mass times gravity. So that'll be 120 newtons down, 120 newtons up. We will stick with things on surfaces. So the y net force will still be 0, but our x net force is going to be some sort of value that ends up not being 0. Alright, so to represent speeding up, happens is your applied force, your Fa, is going to be greater than your frictional force. So this would be a good example of that. We've got 20 newtons being greater than 15 newtons. So this would be a picture that would represent something moving to the right and speeding up. Alright, if you notice, your velocity is to the right. Okay, and our acceleration is also to the right. So try to pick up on a pattern here. So velocity should match where we're moving. The acceleration matches something else. So here's moving to the right and speeding up. Here's moving to the right but slowing down. So we'll work with the same 12 kilogram box, which is going to have 120 newtons of force of gravity and 120 newtons of normal force. Alright, but this time we're going to have 20 newtons to the right of a force applied, and then 25 newtons of the force of friction. What happens here is the force of friction is greater than the force you're applying, so even though you're applying a force, you are going to slow down. Okay? So if you notice, your velocity vector still matches the direction you're moving in, but the acceleration vector now has flipped. It will always point towards the higher force. Alright, because it's the force that determines in what direction you are accelerating. Are you slowing down, therefore accelerating to the left, or are you speeding up, accelerating to the right? Okay? Now, net force is required to find acceleration. So we need to know net force to find acceleration. So for each of these diagrams, we're going to redraw them as with a net force vector. Alright? So what that looks like, here is our first diagram. We've got 120 newtons going down, 20 to the right, 120 newtons going up, and 15 to the left. When you draw a net force diagram, you can still have mass on the inside, but the only force you draw is your net force. Alright? Since in the y direction, everything cancels out, you don't need anything in the y direction. And then in the x direction, you take your two forces. The 20 newtons to the right is positive. The 15 newtons to the left is negative. So that ends up giving you a positive 5 newtons. All right, and then you don't need anything to the left side. Only force on a net force diagram is the net force. And you indicate the direction based on which force was greater. So does the positive side win out or does the negative side win out? Okay, so to see what that looks like for the other situation. So we had 120 newtons down, 120 newtons up, 20 newtons to the right, and 25 newtons to the left. Alright, so again, we don't need anything for force of gravity or normal force because those two cancel each other out. And then we only need one force that adds our negative 25 newtons with our positive 20 newtons and gives us a net force of negative 5 newtons. And then you don't need anything on the other side. Right, so net force diagrams have just the net force drawn on it. Okay? So last thing to take with this is if we take our two net force diagrams, we can find the acceleration of those boxes. So we know our mass is 12 kilograms. And when we're going to the speeding up, so this would be the speeding up example, to the right, we knew that our net force was 5 newtons. And it was positive. Okay, we want to find acceleration, so we take our equation, F net equals ma, divide by m, so that we get A is equal to your net force over your mass, which would be 5 divided by 12, 5 newtons, kilograms, or 0.42 meters per second squared. Okay? So let's look at what happens when we use deceleration. Does this make sense? We ended up with a positive 0.42 because we are speeding up. That's acceleration. Let's see what it looks like when we're slowing down. So we have our net force of negative 5 newtons. Our mass is 12 kilograms still. So those are our two knowns. Same rearrangement to solve for A. So A is equal to F net divided by mass, which is going to be negative 5 divided by 12, which is going to give us negative 0.42 meters per second squared. Alright, that's negative sign lets you know that you're decelerating. Alright, if you're doing this stuff right, the signs show up the way they're supposed to. Okay? So this is a basic introduction to it. We'll practice with this a little bit more, and then we're going to start applying everything we learned with first law to second law, because you can continue using friction equation. You can continue using, force of gravity equals mass times gravity, and all of that stuff helps you solve problems for second law as well. So make sure you do the online assignment, and I will see you in class.